Good morning, everyone. Welcome to the class. We are going to have the third presentation of organic chemistry. That is the last chapter for you all. Students, is very important chapter because out of 40 marks, maybe 10 to 12 marks you are going to get from this chapter. The questions will be from this chapter. So weightage is more for this chapter. Try to understand. It's very important. That is why I'm going slow, because initially they are telling about all the basic things about the chapter. Instructions you all follow to the T. The basic thing which you should know about, do not type in anything in the chat window. I won't be having the access right now. Access in the sense, I don't want to go for that at all. You have a question, anything you're not able to understand, feel free, just raise your hand. I'll take your question then and there. Right. And for the recording, as you can see, already recording has started. So you can go through the recording anytime as per your choice, as per the requirement. We have done in the last class alkanes, alkenes and alkynes. Just in 2 minutes, we are going to finish. I'll just ask the students only to finish the revision. Who can tell me what are alkanes? Come on, raise your hand so that we can finish point by point very fast. What do you mean by alkanes? Anyone in the class? Yes, Anshuman?
Ma'am, hydrocarbons having one single bond.
Did we say like that single bond, or do we specify
Like
certain?
carbon to carbon single bond.
Excellent. Anshuman, when the question is being given, each key, the keyword which you are going to give them, it is very, very important. Whenever you are going to explain the same, you should always say carbon to carbon, or it is being formed with the help of single bonds, right? These are also called as saturated hydrocarbons because they do not show any addition reaction. They go for substitution reaction. Very good. And the structural formula, as you can see, children, it is CnH2n plus 2. And to have that first member, we can start with N is equals to 1. That is methane, ethane, propane, butane, pentane, and hexane onwards. Next was alkenes. Who can tell me about alkenes? Come on fast. Dhruv, very good. Tell me,
Ma'am,
child.
alkenes are unsaturated hydrocarbons with carbon-to-carbon double bond.
Carbon to carbon double bond. A very good morning, Dhruv. Whenever you are there to answer the question, I hope you remember that you have to first of all wish your teachers, and then you have to start your answer. Okay?
Yes,
There
ma'am.
is
Good
some
morning, ma'am.
problem in the mic. If at all you people are not able to hear me, do let me know then and there. Okay? It's not working, I believe, somewhere. Okay. Now, the alkenes are the unsaturated hydrocarbons, and there the identification is carbon to carbon double bond present. The presence of the carbon to carbon double bond, and the general formula for the same group is called as, is being given as CnH2n. Because it is carbon to carbon double bond, we need at least 2 carbon atoms. It will not start from N is equals to 1. It always starts from N is equals to 2. So first 5 members will be given names as, Dhruv, can you tell me the first 5 members?
Yes, ma'am. Ma'am, it would be methane, ethene,
No,
propene,
no,
butane.
child. Why methane? Methane cannot be present, no? Carbon to
Yes, ma'am.
carbon double bond. So 2 carbon
Yes.
atoms are required. Meth is for 1 carbon atom, child.
Okay, ma'am. Got it. So,
Right?
ma'am, would start from ethene, then propene, then butene, then pentene, and then hexene.
Excellent. Very good. Siddhant, you can unmute yourself and tell me about alkynes.
Good morning, ma'am.
Good morning.
Ma'am, first methane,
No,
then
tell me what are alkynes first, child.
ma'am, unsaturated hydrocarbons connected with carbon to carbon single bond.
Carbon to carbon,
Single bond.
single bond. S for single bond, S for
No, ma'am,
saturation.
triple bond. Sorry, ma'am.
Correct. It is carbon to carbon triple bond. Very good. Now I can see Naman also was raising his hand again and again. Siddhant, Naman, can you answer this question? You can tell me the first 5 members of alkynes.
Yes, ma'am. Ma'am, methane is not possible. So, uh,
Excellent.
ethane, and then propine, butane, pentane, Hexyne.
Correct. So first 5 members that is there in your portion, you know it. It is ethyne, propyne, butane, pentyne and hexyne. Till first 4 members you have a difference in name. Otherwise it matches with maths also. Pent, hex, hept, oct, non, right? So meth, eth, prop, but. These 4 names, if you remember, it will be much easier for you to remember for all 10 names, first 10 members of any particular group. Thank you, Naman. Now, children, as we have done these names, saturation, unsaturation, these all points were being discussed. Let's move on to the next part, next step for the same. Whenever we talk about alkanes, first 10 members as we have done, the formula was CnH2n plus 2. One more question I would like to ask. Who can tell me about methane's first, alkane's first member? Come on, raise your hand fast. Okay, Naman, no. Siddhant. Harsh, new one. Yes. Harsh, tell me how to get the first member for alkanes.
Ma'am, we do C. Okay, so
N will be equals
N
to
is
what?
1.
Okay.
So it is C1 and H is 2 into 1 plus 2.
So first member will be?
CH4.
Right. So if I do not want to use the formula again and again, I want next 4 members. What is the way to get it? The easier and the perfect way to get the next 3 members. What we should do?
We just
by
adding CH2.
CH2. So if I'm going to add CH2 here, carbon 1 plus 1, 2, hydrogen 4 plus 2,
6.
Next member?
C3H8.
Very good. And the next member?
C4H10.
H10. So as you can see, the members are being given. If you know the first member or third member or fifth member, whatever number of that number of members are being asked after that, you know, we are going to add CH2 to it, whether it is alkane, alkene, alkyne, irrespective of the group, whether it is saturated hydrocarbon or unsaturated hydrocarbon, 2 consecutive members which are being taken into homologous series, they always have a difference of CH2. This point you have to keep in your mind. It will help you out to get so many times the next members without using the formula going for the chaotic condition. It is much easier. Every time working hard is not so good. Working smart also helps you. Okay. Now let's move on to the first 10 members of alkanes, children. As you can see, for carbon, 1 carbon atom is there. It is meth, then eth, prop, because it is going to have that carbon to carbon single bond. So it belongs to alkane single bond saturated hydrocarbons. What is special right now in the table? In organic chemistry, whenever we talk about the bonding is being done, then for alkanes, it is something special. When we are going to remove 1 hydrogen atom from any alkane, what we are going to remove? We are going to remove 1 hydrogen atom from any alkane, whether it is having 1 carbon atom, 2 carbon atoms, 3 carbon atoms. We are just removing 1 hydrogen. What is the valency of hydrogen? Anyone? What is the valency of hydrogen? Yes, Siddhant?
Ma'am, -1.
It is 1. So when we are going to remove 1 hydrogen from any alkane, that becomes a radical that has a single bond free from the compound. This is complex, particular compound is being formed. When we are going to remove 1 hydrogen, there is 1 valency free on that entire molecule, and that becomes a radical. In place of a compound that becomes a radical, so name has to be changed. This is saturated. No more addition can be done. But when you're going to remove 1 hydrogen, this becomes a radical or a substance which has a free bond. Free bond means it cannot be bonded with other substances with the help of this free valency. Right? So the name will change. This type of arrangement is called as alkyl group. It is being made with the help of alkane by removing 1 hydrogen of alkane, and it is called as alkyl group. What is that called as? Alkyl group. And as per the name, as I told you, for alkanes, the suffix was ane. The same way when we talk about alkyl group, which is being made by removing 1 hydrogen atom from any alkane, this becomes, the ending will be the same, YL. Meth was the Meth tells about that it has, this alkyl group has got 1 carbon atom, and because it is alkyl group, it is YL, methyl. In place of ethane, if you are going to remove one hydrogen atom from ethane, it becomes ethyl group. If you are going to remove one atom of hydrogen from propane, it becomes propyl. If you're going to remove one hydrogen from butane, it is termed as butyl group. So children, you have to just keep in your mind, you have to, if it is being asked, what is the formula of corresponding alkyl group if you are talking about hexane? So it will be hexyl. Why? Because it is going to just remove one hydrogen atom, because still it has number of carbon atoms remaining the same. So it is 6 hex. Because it's alkyl group, so the suffix will be YL in place of ANE. Because ANE shows saturation. No more bonds are being to be fulfilled. Everything is done properly with a single bond. But here, because one bond is free, it becomes alkyl group. And the name changes from alkane ANE. The suffix changes from ANE to YL. So let's do not unmute yourself, just practice with me. If at all we are going to change methane to methyl group, anytime alkane minus one hydrogen atom, keep in mind alkane minus one hydrogen atom, it is going to form alkyl group. It is going to form alkyl group. This alkyl group will be named as per the number of carbon atoms present in the alkane. If it is methane, it will change to methyl group. If it is ethane, it will change to ethyl group. If it is propane, it will change to propyl group. If it is butane, it will change to butyl group. If it is pentane, it will change to pentyl group. If it is hexane, it is going to change to hexyl group till 10. Number of carbon atoms are 10, and we say it is decane, and it is going to change to decyl group. So you just check it as per the number of carbon atoms. The suffix will change because it is no more a compound. It becomes a radical having some valency free on carbon atom. So the name changes from alkane to alkyl group. If at all of you got it, please draw this table. This table is going to help you out to name a number of compounds in organic chemistry, because this is going to give the branching, and branching is being given as per the number of carbon atoms: methyl, ethyl, propyl. Okay, I'll give you just 1 minute. Meanwhile, if anyone has a question, I'll solve the question. I want all of you to draw this table right now. On your own, please write it. I'll give you 2 minutes. It's important so that you remember it. It is not there in your textbook anywhere. Okay? Yes, Naman, you can ask the question, child.
Ma'am, alkyl group is saturated group or unsaturated group?
It is saturated group because it is carbon to carbon, always single bond, child. But the thing is, it has got a free valency on carbon. That is why it is not alkane, it becomes alkyl group.
Ma'am, so it will show substitution, no ma'am?
It has saturation, child. It has saturation, but the thing is, saturation is being changed to unsaturation by removing one hydrogen. So it is now ready to combine with. Saturation means when they cannot combine. But now because hydrogen is being removed, so it has a free valency. It is now free to bond with other substances.
Yes, ma'am.
Any other question? Okay. 1 more minute.
Ma'am, can you show the diagram, the formation of this alkyl?
Definitely, child. Wait a minute. Yes, I will just show that. See, if I'm going to talk about methane, we have done in the formation of organic chemistry. Before that also we have done methane. Formation of methane is like this: carbon to hydrogen, all single bonds. But for alkyl group, what happens here? For alkyl group, we are going to have one hydrogen less. Carbon has 4 valencies. Carbon has 4 valencies. Out of 4, 3 are being saturated with hydrogen, and this is now free valency. Now any other substance which has got 1 valency, maybe chlorine, bromine, iodine, fluorine, these substances can come. Or another alkyl group, say if I'm talking about C2H6 is ethane, C2H5 becomes ethyl group, like 1, 2, meth eth, 1, 2, 3 carbon atoms. Carbon are going to have 3 hydrogen atoms, and this has got 5. So 1, 2. this carbon has got out of 4, 3 valencies being satisfied. This is free. So it can attach with itself with this carbon at this methyl group, and then it will be CH3. When 2 alkyl groups are going to join together, they form alkanes because they always have carbon to carbon single bond. And now by joining 1, 2, 3, number of carbon atoms 3, hydrogen 1, 2, 3, 4, 5, 6, 7, 8. Hydrogen is 8. That means C3H8. It belongs to any of the alkane. Understood? If it is methane, it is having all the 4 valencies being satisfied, but 1 hydrogen is being removed. Now this valency is free, now free to bond with any other substance which has a valency, like here -1, 1 minus bromine, 1 minus iodine, 1 minus fluorine, or any alkyl group. They also are free, having just 1 free valency. So they can join together to form a saturated hydrocarbon. I hope now you have understood this part.
Yes, ma'am.
Welcome. So everyone has written about alkyl group, children. Let's move on to the next part. For alkenes, we have already done last time. Just a reminder that alkenes are having carbon to carbon double bond. Because they have presence of double bond, there is a presence of double bond. We have done the structures for alkenes. If there are 2 carbon atoms, like this. If there are 3 carbon atoms, the structure will be like this. When we talk about the structures, children, once we finish the arrangement, we'll come back to a new term which is being given as isomerism today itself. Then I'll let you know how this placing is going to change the arrangement, and then why they are called as isomers of each other. So this general formula for alkenes is CnH2n, because it has got, how to remember it? Because it has, hydrogen has got double number of carbon atoms, so it has a double bond in between 2 carbon atoms, carbon to carbon double bond. At one place, not each and every carbon will have double bond. At one place, carbon to carbon, they'll be having presence of 1 double bond. The same way for alkynes, it is carbon to carbon triple bond. Double bond and triple bond show unsaturation because they can show the addition reaction. When addition can be done, it is unsaturation. So whether it is double bond or triple bond, both are unsaturated hydrocarbons. Next, homologous series. As a matter of fact, that day when I told you about the portion, children, the very first part from the council with the reduced portion was that introduction of organic chemistry. Unique nature of carbon to carbon atom, the structure, tetravalency, catenation, formation, carbon to carbon single bond, double bond, triple bond, straight chain and branch chain. Today we are going to do that branching as well as how to name the substances. And the next part is isomerism. These 2 topics we are going to do today in the class. And you have 3 functional groups which are being done right now: alkanes, alkenes and alkynes. You have 3 more: alcohols, aldehydes and carboxylic acid. These 3 we'll do in the next class. Now, what are the characteristics of homologous series? And this can be asked for 2-mark question or 1-mark question as a filler question, children, because there are so many other important questions that are being, that can be asked. These things are just to make you understand that members always have same elements, and a functional group also remains the same, whether it is carbon to carbon single bond, double bond, triple bond, or it is alcohols, or it is carboxylic acids, like that. Their general formula remaining the same. By changing the number of carbon atoms or changing the number of N, we can have N number of compounds of the same series. Because they belong to they have the same functional group, so chemical properties will be same. The difference, as we have discussed right now, difference is always CH2. Physical properties will definitely change. Chemical properties are same because the functional group is same, but physical properties definitely will change because density will change. More carbon atoms, more hydrogen, density is going to change. So it will change the physical properties of the substance. Saturated, unsaturated, and how to remember alkanes, alkenes, alkynes. We have already done that table. Identification also we have done in more elaborate form last time. Let's start with the nomenclature and the branching. How to go about the branching, children? Excuse me. When we talk about nomenclature means naming. When a child is born, there is a naming being done. The same way when a compound is being formed, certain naming is being done. The very first time when you have done the naming or the representation of that substances, that was class 8. And that was very irritating for you all because entire year we had the chapter language of chemistry, where we had all the radicals, all the valencies to be learned with the valency chart and the representation. The same way now nomenclature of organic compounds will be done, and we are going to start with alkanes. Children, when we talk about alkanes or alkenes, alkynes, we have to see number of carbon atoms. Along with that, what exactly is the bond? If it is carbon to carbon single bond, the suffix will be always ane. Depending on the carbon atoms, that will be the prefix. We have already done. If carbon is 1, it is methane. Now, it was when the structure is simple, straight chain, then it is the same. But sometimes when we are going to have naming, when we are going to have the branching being done, then what to do? If we are going to write propane, prop means how many atoms? Carbon atoms should be 3, right? So 1 carbon, 1, 2, 3, single bond is being done. All the 4 valencies are being satisfied with hydrogen. It becomes propane. But sometimes, just to confuse you in a arrangement, they can show you in a bent way. Like 1 carbon is being given like this, then single bond carbon here, single bond carbon here. You may feel because it is bent here, it can be a branch structure. No. In organic chemistry, just keep your mind very, very clear. Wheresoever we have functional group, wheresoever we have important groups, we start the numbering from that side. All are the possibilities. We can start from left to right, we can start from right to left, and when we have the continuation of the chain, this also will be termed as a straight chain, longest chain. So here this is not called as branching, it will be a straight chain, and this will be same. After getting hydrogen, number of hydrogen atoms proper, this will be same. Okay, if you see butane here, when we have the longest structure, 1, 2, 3, 4, but is 4. So 1, 2, 3, 4 in the same chain. That is called as N-butane. Normal. It is normal butane or N-butane. This is the common name when we're talking about. But if it is going to have 3 structures, 3 carbon atoms in one go, and with the second carbon atom, if it is going to have, children, one more thing. This is a condensed structure which we are talking about. CH3, CH2, CH2, CH3. This is the structure for 4 carbon atoms. Excuse me. If I'm going to write CH3, CH2, CH2, CH3. Here this and this both are same, because if you see, it is in the continuation. It is being shown as a bent structure, but it is representing the same arrangement. Starting from CH3, CH2, CH2, CH3. Here also CH3, CH2, CH2, CH2 and CH3. So the same way. But if I'm going to show like CH3 here, single bond CH, single bond CH3, and here CH3 is being given. Now in the longest chain we have just 3 carbon atoms. The 4th carbon atom goes as a branched part. And because if it was CH4, it could have been methane. But we have removed one hydrogen. From methane, it changes to methyl group. From methane, it changes to methyl group. And then we have to number the carbon atoms, because everywhere it is carbon atom, we have to specify on which carbon atom methyl group is present. We have to number them. 1, 2, and 3. It is 3-methyl. It is having on the second carbon atom, it has got methyl group, sorry. It is 2-methyl meth, eth, prop, single bond, so propane. Got it? And in common name, when we are going to talk about this normal butane, then carbon to carbon, if carbon is being having just 2 carbon atoms being joined together, carbon to carbon, 2 atoms are there, then it is called as normal butane. It is also called as primary type of carbon. When we have carbon to carbon, on 3 sides carbon is being joined together. This carbon, if you focus on, children, this carbon has got one side this carbon atom, the second side carbon atom, the third side also its carbon atom. Then This type of carbon is called as secondary type of carbon atom. And then we talk about, this is called as iso. It is being called as iso. If I'm going to talk about this type of atom, carbon atom, it is called as iso. But if I'm going to have all the four sides carbon atoms, all four sides carbon atom, like this central carbon atom has got all the four sides directly contacted with, or that bond is being directly found or formed with carbon atoms. This is called as tertiary carbon atom, and this is called as neo position. It is called as neo. It is normal and butane normal, and butane single chain structure, no branching is being done. When single branching is being done, it becomes iso. This is normal naming. Carbon to carbon 1, carbon to carbon 2, carbon to carbon 3. This carbon is being attached from three sides with next to carbon atoms. That is called as iso position. Neo position is possible with 5 carbon atoms, so butane can never show. We have to start with pentane because it needs at least 5 carbon atoms. This is a central carbon atom. 1, 2, 3, 4. All four sides it should be surrounded with the next carbon atoms. Right, children? So if you talk about normal arrangement, they have the naming being done like normal, iso, and neo. Or when we talk about nomenclature, which is called as IUPAC, IUPAC naming, then we have to specify the number of carbon atoms. First, we'll get the longest chain. We number the carbon atoms, and then on which position, which functional group is present, we have to specify. Am I clear? Next, when we talk about alkanes, branch structure, we can right now talk about. This can be, as we have done right now, butane, we are talking about 4 carbon atoms. As you can see, it can be like this. It can have this carbon atom. If you pay attention to this carbon has got 1, 2, 3 on 3 sides. Or from all 3 sides, it is being covered, or it is being having bonding directly with carbon to carbon. This is just 2 carbon atoms. If you focus on any carbon atom on 2 sides, it is not having more than 2 carbon atoms. It is normal condition. It is normal condition. When it is going to have carbon to carbon, 3 sides being surrounded, then it is called as iso. And when all 4 sides are being having carbon to carbon, it is called as neo position. This is being asked a number of times in the board exam, so you should know what is normal, what is iso, and what is neo. Normal means if you see any carbon atom, it will have at the most the sidewise 2 more carbon atoms. Here it will be hydrogen. So this carbon to carbon bonding is being done from 2 sides, not more than 2 sides. But if it is iso, it will have from 3 sides carbon to carbon bonds. And if we talk about neo, it will have all 4 sides being joined together, combining together with carbon atoms. So normal, iso, and neo. These are 3 things which you should know about the normal nomenclature, which is the general naming being done. It is not the IUPAC naming, which we are going to do in the next class after finishing the functional group. Okay. Now we are going to talk about isomerism. Once we are going to have the functional group, children, how it is being attached, where it is being attached, that to be taken care. Right now, as I said, for even branching also, no branching, single branching, 2 branching, second branching is being done. At 2 places, branching is being done. Number of carbon atoms remaining the same, so the group will remain the same. So their molecular formula remains the same. That is why the arrangement in organic compounds having the same molecular formula but difference in structural formula or molecular arrangement, this is called as isomerism. It is like, in simple words, children, if we talk about isomerism, it is like there can be, many boys who have got right now with them 500 rupees or 1000 rupees or whatever. But all will not have the arrangement of the same kind. Some may have just 500 rupee one note. Some may have 2000 rupees just one note. But there can be some who are having 2000 rupees with 500 rupee note, or they can have 100 rupees note. So total amount remaining the same, but the arrangement can be different. This is what we talk about isomerism, and the structures, how many structures are present. Each structure is called as the isomer for the same. Once again, in organic compounds, when they have same molecular formula, but there's a difference in the structural formula or molecular arrangement, the branch structure, then it is called as isomerism. The phenomenon is called as isomerism, and the various structures that are being shown with the help of same are called as isomers of the same. In your portion, with the reduced portion, we have just isomerism of structural kind. In structural part, there are two: chain isomerism, and the second is called as position isomerism. Today I'll show you, due to change in the presence of or the position of double bond and triple bond, we are going to focus more on say position isomerism. And the second one, when we are talking about the nomenclature, next time when we finish the functional group, we are going to talk about chain isomerism. Okay, children, let's start with the structure which is being given as pentane and all we have done, iso and neo. When we talk about alkenes, children, alkenes, as you know, ENE, that means it has got a double bond. Carbon to carbon double bond is present. That is the essential part of that substance. As you can see, ethene has got 2 carbon atoms. So just having 2 carbon atoms and there is the presence of double bond. So there can be no other possibility. If we talk about propene, children, here, when we can see there are 3 carbon atoms, either you go for carbon to carbon here double bond, or you can go, children, if it is CH2 double bond, single bond, you can just take it. Okay, there are 3: meth, eth, prop. The time I told you last time how to go by the structure, let's start with the same way. So it will be much easier for you to understand. Just a minute, huh? There should be no confusion. Let's start with the way I told you last time in the class. It is prop, meth, eth, prop. Meth, eth, prop. In the first structure, as they have shown you, that carbon to carbon double bond is present here. Let's see this carbon to carbon double bond present here. Out of 4 valencies, 2 are being done here, 2 are left. For this carbon, 1, 2, 3 are being already done, so 1 is left. For this carbon, 1 valency is satisfied with the help of another carbon atom, and 3 are left here. So let's put this hydrogen here. The unique feature about organic chemistry here is, if at all there are 3 carbon atoms, we have to see the numbering, how to do it. Because every carbon atom is being bonded, but the unique feature is double bond. If it is being present from this side, this carbon to carbon double bond is there, numbering will start from 1, 2, and 3. But if you're going to have carbon to carbon double bond present here, then numbering will start from here, 1, 2, and 3. So if you are going to put the bond carbon to carbon double bond this side or this side, as per organic chemistry, the naming is being done accordingly. These two are just the same. These are not 2 forms or 2 forms of or isomers of the same. It is, they're going to start the numbering being done from here. Okay. Let's see, when we are having 4 carbon atoms, bute is being done. 4 carbon atoms, 1, 2, 3, 4. If I'm going to put here double bond, is there anyone who can help me out to complete the 4 valencies of carbon? Anyone in the class? Yes, Arya?
Yes, ma'am. The first carbon atom will have 2 hydrogen.
Very good.
Then the
And this
second
one has
will
got,
also have 2.
sorry, this carbon, 1, 2,
hydrogen.
and 3.
1 hydrogen.
Yeah, very good.
And then
This carbon,
2 hydrogen.
very good.
And
This,
3 hydrogen.
very good. So if I'm going to have one structure like this, okay, or I'll have, because I have 4 carbon atoms, right? So 1, 2, 3, 4. If I want this carbon to carbon, this is double bond. So how to fulfill the valency? Saket, please answer the question. Let me just draw the structure. Help me out.
Ma'am, so for the first one, we will have three
Very
atoms.
good. Correct. For this carbon?
Ma'am, 1.
Very good. For this carbon?
Ma'am, 1.
Very good. For this carbon?
Ma'am, 3.
Very good. So when we are going to have the structure, the position of here, as you can see, if I'm going to number, there are 4 carbon atoms. If I'm going to start 1, 2, 3, 4. This here, 1, 2, 3, 4. Initially, when we, thank you, Saket, you can mute yourself. Children, when we are going to talk about the numbering being done, we have to start where the double bond or triple bond is present. That is the unique feature of that organic compound, right? Because we have done just 3 functional groups, carbon to carbon single bond, carbon to carbon double bond, and carbon to carbon triple bond. Right now we are talking about carbon to carbon double bond. That is a unique feature. We are going to number the carbon from the same. So here, as you can see, it is in the terminal position. So we are going to have 1, 2, 3, 4. The unique feature is when it is being present in between 2 carbon atoms. Any which ways, whenever we have double bond or triple bond, it will be always present in between 2 carbon atoms. What you have to say, whatever is the lower position, as you can see this carbon to carbon, it first is 1 and 2. If the carbon to carbon double bond is present and that is present in between carbon 1 and carbon 2, then numbering is done as C1, whatever is the lower number that is being taken, because it is being, so how to number it and name it 1, 2, 3, 4, meth, eth, prop, bute. It has got double bond, so the name will end with ENE. And which carbon atom it has present? It is present double bond in between first and second. So first will be taken, whatever is the lower number. So it will be butene 1, bute 1-ene or butene 1. Okay, whenever we have any name and number, there should be a small dash to differentiate always. And when there are two numbers are being differentiated or being represented with the help of comma. When we are going to have 2 numbers or 2 numbers, and after number, whenever we have to start the name, we have to put a small dash. That is the important feature when we write the names of any structures in the IUPAC naming. Okay. Now, as you can see in the second structure, number of carbon atoms are same, but when you number it 1, 2, 3, 4. Now, as you can see, this double bond is present in between second and third carbon atom. Right, second and third carbon atom. So the name will be bute 2-ene, bute 2-ene or butene 2. So when the change, the structure remaining the same, structure is what? When we talk about meth, eth, prop, bute, C4H8, CnH2n. When we count the number of carbon and hydrogen atom, in both the positions same, but the position of functional group is going to change from first to second. This is called as position isomerism. The phenomenon is called as position isomerism, and these two are position isomers of each other, because position of double bond is going to change from one to another. That is why it is called as position isomer. So in the presence of, or in the case of double bond and triple bond, it is very, very easy to see that the position of double bond or triple bond can change from one carbon atom to another one. And that is why they are also called as position isomers of each other. And the phenomenon or the process is called as isomerism, or the tendency of carbon atoms is called as isomerism. Any question? Anyone? Yes, Parth, you can ask the question, child.
Am I audible?
Yes, child, you're audible.
So here for isomerism, the butene compound will only show 2, right? 1 and 2.
Yeah, because if you go for the third carbon atom here, numbering will start from this side. So again, it will be in between 1 and 2.
So the numbering can be from any side.
Yes, in organic compounds, because see, when we have difference in the arrangement, then we can have the difference in, numbering. So we always, like in English language, we always start writing from left to right. Right. In a periodic table also, when we see the tendency of increasing, decreasing order in a period, we always start from left to right. Because there's a difference. We start with metals, then metalloids, then non-metals, then noble gases. Here it is carbon to carbon. There's no change. All are carbon atoms. So wheresoever important group is present, we start numbering from that side, whether it is left side or right side.
Okay, ma'am. And isomerism will start from ethene.
Ethene, no. Ethene, where ethene will have? Can we have any other position where I can go for the carbon to carbon double bond?
No,
Hydrogen cannot expand, cannot have more than one valency. It has just one electron. So it will
Okay.
always show single bond. Right, child? So
Yes.
at least,
Thank you,
at
ma'am.
least 4 carbon atoms are required to show the variation. Even 3 carbon atoms also numbering will be same. If this is present here, this becomes 1 and 2. If it is on the other side, this becomes 1 and 2. So this also will have the same arrangement. This cannot be the 2 isomers. It is 2 arrangements, but isomerism is not possible. It starts from C is equals to N is equals to 4. Yes, Harsh, you can ask the question, child.
Ma'am, is butane and butene one the same thing?
Butene will tell you it is carbon to carbon double bond is present, and it has got 4 carbon atoms which are being added together as unsaturation, and it follows CnH2 in formula. Butane 1 is the correct naming when we are going to when we get to know that double bond is present in between first and second carbon atom.
Okay, ma'am. And can this butane can it happen in this alkane as well?
Alkane.
Yes.
See, child, we are talking about ENE. ENE is ene means double bond. Alkanes have single bond. There is no difference. All carbon to carbon single bond. How to differentiate?
Okay, ma'am. Okay.
When
And
there's
what?
when there's a difference, we can specify.
Yes, ma'am. And alkyne?
Alkynes, definitely. We are going to have that in the next slide. We are going to talk about alkynes only.
Okay, ma'am. Can I do the third one, the chain isomer?
Chain isomerism we are not doing right now today.
Okay.
Because if we'll take both, no, you'll get confused. So I'll take today position, and next time after finishing the next 2 functional groups, we'll go for the chain isomerism, children. I want to go a bit slow so that you understand. I don't want to just finish it. Yes, Tirtham, you can ask the question, child.
Ma'am, on the screen where propene is written, why is the numbering start? Why is the numbering start from the right side?
Why do we start from the
Right side, the numbering 1, 2, 3.
From here?
Yes,
This
ma'am.
one. This is wrong. Just to show that this is wrong. Because when we have any functional group, the numbering has to start from the same side. That is what we have shown here.
And ma'am, isomerism is only when the compound is in its pure form and not added to any functional group, no?
There is no change. Child, if we talk about the condensed formula, it is same. With the condensed
if there are if propene is there and the double bond is in the first and second atom from the right side, and then if a functional group is added to the first carbon,
no. Once we are going to have addition of any functional group, then it is a unique feature. Functional group will change the entire formula also, child, no?
Yes, ma'am. So it will act on the same formula only, no?
No. If we have what functional group we are going to add? Child, tell me.
Ma'am, like COOH or CHO. Aldehyde.
O will come, no? From where we'll get with the same molecular formula, from where we'll accommodate this oxygen here. It says when the molecular formula is same and the arrangement is different, it is called as isomer. We cannot add or subtract anything with the same thing. I said you have 500 rupees. There is another boy, maybe 10 more boys with 500 rupees. Maybe one boy all 10 rupees note. Maybe one boy with all 20 rupees note. Maybe one boy with all 50 rupees note. There can be one boy just 1 rupee of 500 rupees. Got it?
No, like if the functional group, the other functional group, suppose is added on the third carbon atom, and on the same side the functional group is added on the first carbon atom, then the formula is same but the structure is different, no?
Structure, the position will be changing, then it is called as position isomerism. Like, okay, listen, I believe, okay, you want that if there is one OH group being present, right?
Yes,
OH group is present. If OH group is present on the first carbon atom, this is different. If I'm going to have here hydrogen only and it is present here, OH group present here, position of functional group is going to change. This also comes under the heading of position isomerism. This we are going to do once we are going to have one or two more functional groups like aldehydes, like alcohols and carboxylic acid in your portion.
okay, ma'am.
Definitely. The structure remaining the same, the molecular formula remaining the same, and the position is going to change on the carbon atom. It can be first carbon atom, it can be second carbon atom, but if it is here, this becomes second carbon atom. This will not be taken as third carbon atom, children. So that you have to keep in mind. In organic chemistry, it is not always like, we are going to talk about this. So if it is first, this is second. If it comes here, it will not be fourth will. This becomes first and this becomes second. If it is going to turn to this side. Okay. So this you have to keep in your mind. Yes, definitely. This is 1 and 2. These are two isomers of alcohols. Correct.
Ma'am, this third carbon atom in the line can be said carbon atom 3 because if a double bond is present, no?
Then which functional group is present, which to be given more importance, then it is that another thing. And in your portion, it will be always one functional group till class 10, only one functional group present along with alkyl group to name the substance. You do not have two or more than two groups present throughout leaving alkyl group or halogens.
Ma'am, but in that case, how to name it then?
Child, we have not done any rule of nomenclature. So once let me finish that, then I'll take you.
Yes, ma'am.
Okay, just remember this question. Maybe next class itself, after finishing the functional group, I'll give you the points for the naming and then you can ask me the structure. It will be much easier for me to explain with the rules. Any other question, child? Ahan, you have a question? Please ask me.
Yes, ma'am. Will isomers have different chemical properties or physical
Definitely.
properties?
That is why they are being identified. There are some properties that are being shown by one isomer and the second isomer remains inert to that reactions. It is like, like when you're having a free hand to hold certain things and so you're free to give it to someone, and when it is there in the center position, a person cannot come and take it. So functional group is going to be at a place where it cannot show its function or cannot be functional as such. Just presence is being done. So if the position is going to change, definitely it is going to change the properties of the substance. That is why actually scientists, they got to know about that having the same formula, there can be a difference in their properties due to the change in the position or change in the chain of these substances. So they got to know about what is isomerism, and that told them about that gave them the clue to go further about the studies about these substances, and they got to know about isomerism and isomers.
Okay, ma'am. Thank you so much.
Welcome. So children, just last part in 2 minutes, I'm going to talk about alkenes. We have done, alkynes we are going to do. Here it is carbon to carbon triple bond. Here when we have just 2 carbon atoms, there is no choice. When we have 3 carbon atoms, if it is in between these 2 carbon atoms, this is not possible. We are going to start with 1, 2 and 3. Right? And if it is starting from this type of carbon atom, this becomes 1, 2 and 3. Okay, so when we talk about these 3 carbon atoms, wheresoever it is present, this becomes a terminal position and naming will start from this carbon atom. If it is present here, this is going to be discarded and we have to start with 1, 2 and 3. When we have 4 carbon atoms, then we have one terminal position and one middle position to accommodate the triple bond. One terminal position, one middle position, and depending on the position of the triple bond, the name is being given. It is but1-ine because it is present in between first and second carbon atom. As I told you, the lower number is being taken out of 1 and 2. 1 is lower. So but1-ine. And here, as you can see, the word is being given dash number dash word. So this is the basic rule when we write the names. Okay. The second point when you are going to see, it is in between 1, 2, 3, 4, in between second and third carbon atom. Out of second and third, lower number is 2. This is called as but2-ine. Okay, children, this is a basic arrangement. When there is a change in the position of a functional group, it is called as position isomerism being shown. And these are two position isomers of butane. Butane 1, butane 2, or but1-ine, but2-ine. Am I clear? With this, I can see it is 11:49 already. So, good morning and thank you, boys. You may ask me the questions if at all you have. In the next class, we'll do 3 more functional groups. We have done alkanes, alkenes, and alkynes. I hope you people are more familiar and perfect with the questions. Now, after this, what I want you all to know, that is, there are 3 more functional groups in your portion: alcohols, aldehydes, and carboxylic acid. In the next class, we'll finish that next 3. And after that, if time permits, I'll give you the rules for IUPAC naming so that we can we are perfect with the same. If anyone has a question, you can ask me. No one? Okay, so good morning and thank you, teachers. Good morning and thank you, boys. Please read the portion taught so that we can you can have some more questions and you can understand pretty well.